question, we will be learning the relationship between force, mass, and motion, and we will be devising a strategy for solving force and motion problems using Newton's second law. Let's take a look at this question. The following setup in figure 4 shows three objects, M1, M2, and M3, accelerating to the right at an acceleration A due to an applied force F, such that the masses M1 and M2 do not move relative to mass M3. The objects M1 and M2 are connected by an inextensible string that passes through a light frictionless pulley. You may assume all surfaces to be smooth and the effects of friction neglected in this question. Part 1 asks us to consider only the forces on masses M1 and M2 to show that the acceleration A can be given as a ratio M2 over M1 times g, where g is the acceleration due to free fall. Now, how should we attempt to solve this question? Let's look for some obvious hints. Well, the question mentioned that we need to consider only the forces on masses M1 and M2. With this hint, we will know that we'll need to draw free body diagrams of masses M1 and M2. So let's proceed to draw the free body diagram of mass M1. Now M1 will have its own weight, so let's have the weight acting from its center of gravity, and let's call this weight M1g. At the same time, M1 also experiences a normal contact force acting vertically upwards. So there's this contact force. Let's call this N1 acting from the surface of contact. Now, M1 is connected to a string, and this string will exert a tension to the right. So let's draw this tension. And let's call this tension T1. Is there any friction acting on mass M1? No, because the question has already mentioned that we assume all surfaces to be smooth and effects of friction to be neglected. So the surface between M1 and M3 is smooth. There's no friction. Let's now proceed to draw the free body diagram of mass M2. Similarly, mass M2 also has its own weight acting vertically downwards. Let's call this weight M2g. At the same time, it also experiences a contact force. This contact force is no longer vertical, but acting horizontal to the right. Let's call this N2. Why is it acting horizontally to the right? Because the contact surface is vertical. Similarly, there's no friction between the surface of M2 and M3. But there's still one more force that we need to draw, and that's the tension. Now, this tension acts upwards on mass M2. So let's draw this tension, and we call it T2. Now again, M2 does not move with respect to mass M3. Why? Because the question has already stated that masses M1, M2 do not move relative to mass M3. So, from this statement, we can conclude that N1 is equal to M1g and T2 must be equal to M2g. So, all the forces acting vertically on mass M1 will add up to be 0. And this will imply that N1 plus the negative of the weight M1g will be equal to 0. Now, since the weight is acting downwards, that's why it's given a negative sign. Hence, N1 is equal to m1g. Now, T1 must be the force that is causing m1 to accelerate to the right, because the three masses are all accelerating to the right, and T1 is the only force acting to the right, and T1 acts on m1. Therefore, we can conclude that T1 is equal to m1a. Now, let's look at mass m2. Mass m2 does not move with respect to mass m3. So, like mass m1, all the forces acting vertically on mass m2 will add up to be 0. And we imply that T2, which is upward force, plus the negative of the weight m2g must be equal to 0. So T2 is equal to m2g. Now N2 will be the force that is responsible for pushing m2 with acceleration a. So we can say that N2 is equal to m2a. Now, is there a relationship between T1 and T2? Yes. The question has mentioned that the two masses are connected by a light frictionless pulley. This light frictionless pulley will cause T1 to be equal to T2. And we say that this 2 tension is equal to T for simplicity. And with that conclusion, we can say that T is equal to M1A and T is equal to M2G. Now, since T is equal to M1A and is also equal to M2G, we will say that M1A is equal to M2G. And by rearranging, we can see that A is actually M2 over M1 times G. And hence, we have proven that the acceleration A can be given as the ratio M2 over M1 times G. Now let's look at the second and final part of this question. Hence or otherwise, derive an expression for the force F in terms of M1, M2, M3, and G. Now, how should we attempt this question? We're going to draw a free body diagram for all the 3 objects combined together. Meaning, I'm going to draw a free body diagram of the system. This system consists of 3 objects, M1, M2, and M3. So I'm going to use a box to denote this system. So I just draw a box to box out this system. And I'm going to draw the forces acting on this system of 3 objects. So there will be the weight of the system, let's call it W, and there will be a contact force acting on the system, let's call this N. There's also a third force acting on the system, which is this force F, which is already given. Now the internal forces acting between M1 and M3 and between M2 and M3 are ignored because we are now looking as a whole system. We are only interested in forces acting on the system as a whole. Internally, we are no longer interested. So, from this free body diagram of the system, we can say that all the vertical forces add up to be 0. Why? Because this system doesn't move vertically. It is sliding to the right with an acceleration A. There is no motion vertically. That's why all the forces vertically acting on the system will add up to be 0. And this will imply N in the upward direction plus the negative of its own weight will be equal to 0. So the contact force is actually equal to the weight of the system. Now horizontally, there is a force F, and it is the only force acting on the system towards the right. Why? Because there is no friction as mentioned in the question. There's no friction between the floor and the system, this combined mass system. And this force is responsible for causing the system to accelerate with acceleration A. And the combined mass of this system is the sum of all the three masses, M1 plus M2 plus M3. And these three masses are accelerating to the right. The combined system also accelerates to the right. Therefore, we can say that F is the only net force that causes the system with a combined mass to accelerate to the right with acceleration A. And rewriting this, we will have M1 plus M2 plus M3 holding add together times A. And from the previous part, we have found that A is actually M2 over M1 times G. And hence, we have derived an expression of the force F in terms of M1, M2, M3, and G. And I hope with this example, you have a better understanding of free body diagrams and how it is used to solve for unknowns using Newton's second law. Thank you.